Good evening, everyone. My name is Hamza, and today I'll be discussing how we can incorporate explainable and responsible artificial intelligence into the development of uninformed and informed search algorithms. As AI continues to be integrated into various fields, it's crucial that we design systems that are both transparent and ethical. I will take you through the strategies that can be applied to ensure this. Okay, here is a quick overview of what I will be covering today. I will begin with an introduction to explainable AI and responsible AI. Then I will dive into how these concepts can be applied to uninformed search algorithms like BFS and DFS. After that, we will discuss their application in informed search algorithms like star. Finally, I will show some Python codes of how this can be implemented. Let's start by defining two key concepts: explainable AI and responsible AI. Explainable AI aims to make AI models more understandable and transparent to humans. It's critical because many AI models function like black boxes, which means users often don't understand how decisions are made. Then when it comes to responsible AI, on the other hand, focuses on ensuring fairness, accountability, and privacy. It's about making sure that AI systems are not only efficient but also ethical and user-centered. Both of these are essential in modern AI development. Now, let's move on to uninformed search algorithms like BFS and DFS. These are algorithms that do not have any prior knowledge of the goal state. To integrate explainable AI, we can make these algorithms more transparent by clear documentation, explaining the search process, such as which nodes are being explored and why. Then, by visualization, creating tools that show how the search is progressing in real time, allowing users to see each decision point. For responsible AI, accountability implement logging mechanisms so that we can trace how and why a particular path was chosen. Now, let's look at informed search algorithms like star and BFS. These algorithms use heuristic to make searches more efficient and incorporating explainable AI. And by incorporating it, we need to do the following: justify heuristics, clearly explain why a particular heuristic is being used and how it impacts the search process. Then, scenario analysis. Let users compare different heuristics and see the impact on performance for responsible AI. We ensure fairness by bias assessment, checking for any inherent biases in the heuristic or data. Okay, now when we continue to the next slide, that is all about ethical considerations and governance. As AI becomes more embedded in society, it's important to ensure that algorithms, including such algorithms, are not only efficient but also ethical. Let's start with bias audits. Regular bias audits help identify whether the algorithm favors certain groups over others. Next. Next is algorithmic fairness, ensuring that such results or decisions made by the algorithm are equitable and not biased towards a specific demographic or data set. Then we have user involvement in design. Involving users and stakeholders during the design phase is essential to identify their needs and prevent the exclusion of minority voices. Okay, next, I will quickly show you a practical example of how we can implement these concepts using Python. This code performs a BFS search and includes explanations for each step of the process. So now, let me open Visual Studio to visualize the codes. And the codes hope are visible very well. This code performs a BFS traversal of the graph. It visits nodes level. It visits nodes level by level, tracking the path and explaining each step. The code provides clear explanation about which node is visited and why certain nodes are added to the queue. For example, this makes it easier to understand and debug the algorithm by printing out its. So I conclude by let me go back to the conclusion slide. So I conclude by, in conclusion, therefore, by adding explanations to each step, this BFS implementation aligns with the principle of explainable AI, ensuring that users understand how decisions are made within the algorithm. This type of feedback can improve trust, allow debugging, and help identify any biases or errors in the algorithmic behavior. So, for explainable AI, it improves transparency, trust, and usability in such algorithms by making their decisions explainable. And on the other hand, reasonable AI ensures fairness, accountability, and privacy. So my final thoughts, as AI becomes more integrated into various industries, the adoption of explainable and responsible AI will become increasingly important. Thank you for watching. Have a nice day.